We're going to talk about dividing complex numbers in this video. So if you see here, I have two complex numbers being divided. I have 5 plus 3i divided by 1 minus 2i. When you do a dividing problem, it's actually best to rewrite it so that it's in a fraction form. And so we have 5 plus 3i divided by 1 minus 2i, same thing. But this can't happen. And so the question is, why can't it happen? And I want to remind you of one rule. We have a rule that says you can't have a square root in the bottom. And remember what I is. I is the square root of negative 1. So technically here, because of the square root of negative 1 in the bottom, or I in the bottom, this actually, we can't leave it like this. And so that's where the division comes in. We're actually not going to go through and divide, really. What we're going to do is we're going to fix this I being in the bottom. So I want to remind you of this. Do you remember what we talked about here when we had our complex conjugates? So we had 1 minus 2i and 1 plus 2i. But do you remember what happens when we multiply those? If we look at the box and actually multiply those, we get 1 minus 2i and 1 plus 2i. So we get 1 minus 2i plus 2i, and then this would be minus 4i squared. Remember, I squared is negative 1, so we actually get a 4. And so the big deal here is that 2i and negative 2i cancel out, and so our answer is just 5. It's just the 1 and the 4 put together, and the i's disappear. Well, that's a big deal for us because that means I is gone now, and so we no longer have I. So what we're going to do is, remember, we're trying to get rid of I here on the bottom. So what we're going to do is, we know if we multiply by the complex conjugate 1 plus 2i, then we know that the i's are going to disappear on the bottom. But to be legal, remember, when you're simplifying a fraction or working with a fraction, whatever you do to the bottom, you have to do to the top. So we also need to take the top and multiply it by 1 plus 2i. And so in this problem, we're going to end up having to do two boxes. We'll need to do a box for the top to multiply 5 plus 3i and 1 plus 2i. And then in the bottom, we're going to have to do a box for 1 plus 2i and 1 minus 2i. So we'll have two boxes. We'll have an answer on the top fraction, answer on the bottom. So let's go with 5 plus 3i here. So we get 5, 3i, 10i, and then we get 6i squared, and the I squared is negative 1, so we really get minus 6. So on the top, we'll get negative 1, because we get the 5 and the negative 6 together, plus on 13i. On the bottom, I know we already did this, but it's good practice. We get 1, and then we get 2i and minus 2i, and then we get negative 4i squared, and I squared is negative 1, so we get a positive 4. So the 2i and negative 2i cancel. 1 plus 4 is 5. And now this is actually going to be our answer. We get negative 1 plus 13i all over 5 is going to be our answer. There's really no other math to do there. So as long as you don't have I in the bottom, you're good to go. So then we have a couple more examples here. Let's make them bigger so we have more room to work. Alright, so this would be a good time to hit pause and try this problem on your own, or if you really need to watch me do this, you can. So I'm trying to get 1 plus I. I can't have that I in the bottom, so I'm going to multiply by the conjugate, 1 minus I. And I have to take the top and multiply that also by 1 minus I. Whatever you do to the top, you have to do the bottom, vice versa. And so we're going to have two boxes here. So let's just work out the top right now. I've got 2 minus 7i and 1 minus I. So we get 2 minus 7i minus 2i. And then this would be plus 7i squared, but I squared is negative 1, so we get minus 7. So on the top, we'll get 2 minus 7 is negative 5, and then minus 9i. On the bottom, we'll go ahead, 1 plus I and 1 minus I. So we get 1 and negative I and negative I squared, which would be a negative 1, so we get positive 1. So on the bottom, the i's cancel out, and we just get a 2. And so that would be our answer. Okay, we'll do this one now. And so I'm trying to get rid of the I in the bottom, so I multiply by negative 1 plus 2i. Same thing on the top, negative 1 plus 2i. So we have, let's see here, we have 3 plus 11i and negative 1 plus 2i. So we get negative 3 and minus 11i. And what is this, 6i. And 22i squared, which that's a negative 1, so it would be negative 22. So on top, we'll get negative 25 minus 5i. On bottom, we have negative 1 plus 2i and negative 1 minus 2i, so we get positive 1 there. We get minus 2i, positive 2i, and then minus, let's see here, that would be 4i squared, which would be plus a 4. So the 2i and the negative 2i cancel, and we get a 5 on the bottom. 1 plus 4 is 5. Now we're actually not done with this problem, because if you notice, every single one of these terms has a 5 in it, so we can divide by 5. So we've got a 5 there, and a 1 there, and a 1 there. So we get negative 5 minus I over 1, and we really don't need to put it over 1, so it's negative 5 minus I is our answer. Alright, one last thing I want to talk about, and you actually might want to watch this a couple times. I also put a video on your iTunes U that talks about this a little bit also, so maybe you want to watch that too. But the powers of I is important. So we have I, and then we have I squared. Now we know I squared is negative 1, that's kind of the definition. Okay, but now what if I go to I cubed? What is that going to be? What we're going to do is we're going to break that up. I'm going to break that up to say that I have I squared times I. Because remember, I is just I to the first, and when you multiply your bases, you add your exponents. And the big deal here is, if I have I squared, I know I squared is negative 1, so I can replace that with negative 1 times I, and so really I cubed is the same thing as negative I. Alright, what about I to the fourth? What is I to the fourth? Well, I can split that up into I squared times I squared. And because I do that because I know that I squared is negative 1, so this first one is going to be negative 1, and the second one is going to be negative 1, and negative 1 times negative 1 is 1. So what's really cool about this is that I to the fourth is 1. So now as I go on to talk about I to the fifth, instead of breaking everything down in I squared, I'm going to break it down in I to the fourth, because I to the fourth is 1. So I to the fifth is I to the fourth times I, and I know I to the fourth is 1, so now I have 1 times I, so I to the fifth is the same thing as I. I to the fifth is the same thing as I. And if I go I to the sixth, well, that's going to be I to the fourth times I squared. I to the fourth is 1, I squared is negative 1, and 1 times negative 1 is negative 1. So I to the sixth is the same thing as I squared. And we can keep on going. And what our goal is to do is to get to where we can use a big number. Like let's say I to the 81st power. Seems kind of scary, I know. But here's what I'm going to do. I'm going to go I to the 80th times I to the 1. And here's why I'm doing that. If your exponent, 80, is divisible by 4, that means you're going to get the same answer as if it was 4. So 4 goes into 80 20 times. So that means that this is going to be the same thing as I to the fourth, which is 1 times I. So this I to the 81 is really just I. Let's look at I to the 23rd. I'm going to, oops, that's supposed to be an I, isn't it? So I to the 23rd. So I've got I to the 20 and I to the 3rd. Well, 20, let's see, that's divisible by 4, right? 5 times. So basically I'm going to have a 1 5 times, but I'll just write 1. Well, I to the 3rd, I can break that up into squared and 1. So I still have a 1 times I squared is negative 1 times I, and so this all comes down to be negative I. So tomorrow in class we'll actually work on more of those to see what you can do and some of the crazy ones that you can come up with.